Welcome back to this tutorial on financial modeling using Kaluta projection methodology. Last time we did an exercise of locating the flows in our projected numbers that resulted into us having unrealistic business valuation metrics. Now let us proceed to introduce the new business valuation metrics that have been introduced in order to address the shortcomings that are inherent in traditional business valuation metrics that we have thus far used. So let us start with internal rate of return. So the modern business valuation metrics that is used is called modified internal rate of return. And this one has been introduced to address two main shortfalls of internal rate of return. The first one is that internal rate of return assumes that the positive cash flows of the business is reinvested using internal rate of return instead of using cost of capital. This is unrealistic because normally the generated cash flow will need to be compounded or will need to be reinvested with the opportunity cost, which is the cost of capital, and not the same rate that was used to generate them. Okay, so using the internal rate of return is actually inflating the projected future cash flow. So that's why the modified internal rate of return was introduced. And the other point is that when you have unconventional cash flow, that means the conventional cash flow is the situation where the initial outlays are negative and followed by a series of positive cash outlays. That is the conventional cash flow. So unconventional cash flow happens when you can have negative cash flows even after the first initial outlay. Okay, so in that situation, IRR may produce multiple IRR instead of one. Okay, and so the modified internal rate of return addresses this, where you will only have one internal rate of return. So let us see how the modified internal rate is done. First, we compute it manually, and then we will use Excel formula. So for modified rate of return, let us start with picking our unlevered free cash flow and number of years there and bring them here down. So let me double tap here and start with equal sign, and sorry, not there, here let me type unlevered free cash flow, and then start with equal sign, pick the figure for unlevered free cash flow, which is here, press enter, and here should be year indication. So click there, start with equal sign and click the year, which is here, press enter. Okay, let me check this format here. Let me copy this format. Use copy and then put it here. Okay, then let me tap to remove that. So I can select these two and fill them to the rest of our projected period. Okay, now let's see how modified internal rate of return works. It discounts all future negative cash flows using the financing rate of the firm, that in our case is the cost of debt, okay? And it compounds the positive cash flows using the cost of capital to establish the future value of expected cash flow, okay? So there are two components there. For the first component, discounting the negative numbers, we don't have negative numbers, future cash flows in our case here. You can see both from year 1 to year 3 are positive. So we don't have negative cash flow, negative future cash flow to discount it to the present value. And for positive future cash flows, that means we need to compound them to get the future value at the end of the period. So I put here, I'm going to put here computation for compounding factor. Compounding factor. To compound our future cash flow, expected future cash flows, to compound them to the end of, to establish future value at the end of the period. So for year 1, let me put the formula there. Start with equal sign, open the bracket. The compounding factor will be 1 plus, we are compounding them using the cost of capital. So our cost of capital is here at B54. So I need to lock this cell so that when I drag this formula it will always pick from B54. So I start with $, and then type B, and then $, again, and then type 54. We use this long way because we are using Android, okay? If it was Excel, just click there and then use F4 to lock the cell by making it to be absolute cell, absolute reference, okay? So after that I close the bracket, so that is 1 plus R, compounding to the power of number, okay? For year 1, we are compounding the cash flow in year 1 to year 2, that is the first year, and to year 3, that is the second year. So the compounding n here is 2 for year 1, okay? So press enter. Okay, let me fill this to the rest and then I will adjust the compounding formula, okay? For year 2, you can see there in the formula bar, the compounding now for year 2 is only 1 year, from year 2 to year 3. So instead of 2 here at the end, I replace it with 1, okay? And for year 3, it is already now. So the compounding factor here is 0, okay? N is 0. So we have established our compounding factors. Now we establish our future value of cash flows, starting from year 1 here, which is, start with equal sign, take the unlevered free cash flow, multiply by, let me use this pad here, unlevered free cash flow multiply by compounding factor. Press enter, and this is true, so I tap to fill this. I tap to fill this to the rest of our projected period to establish future values. Then then what we do is simply having our sum of future values at the end of the period, sum of future value here at the end. So all the intermittent positive cash flows have been compounded to establish their future values at the end of projection period, in this case year 3. So here we simply sum them. We sum them starting from year 1 here up to year 3. So now our cash flow is being reduced to two components here. The first component is initial outlay. So let me call it adjusted cash flow. Adjusted cash flow. In year 0, it's just the same, which is start with equal sign, which is this one, unlevered free cash flow in year 0. It is already now, so there is no need to discount it. And in at the end here, the figure is simply this one. So our cash flow now, adjusted cash flow, has two occurrences. One is initial outlay, where all negative cash flow have been discounted with finance costs, but we don't have negative future cash flow in our projection. We only have positive cash flow. So the first initial outlay in year 0 is the one that is remained. And another occurrence is some of the future values, expected future values. So we only have 2 points. Now, the modified internal rate of return is now applied to establish by establishing the annual compounded annual growth rate from here, year 0, to this future value here, to establish compounded annual growth rate from year 0 to year 3. So the formula for compounded, which is now our modified internal rate of return, is, start with open the bracket, okay, start with equal sign, then open the bracket, take the final figure of the cash flow, this one, divide it by the initial cash flow. Because it is negative, let us start with negative number and pick here to turn it to positive. Okay, so after dividing, close the bracket, and we now have to apply the square root of this product, the square root of number of years. In this case, n is 3. So for a square root for Excel, what we can do is to use this compounding. First let me open the bracket, okay, and then let me put the compounding sign there, and then open the bracket, then take 1 divided by n, okay, and n in this case is 3, okay, and then close the brackets. So we are compounding it. So after that you minus 1, okay, to establish the annualized growth rate, compounded annualized growth of rate. So minus 1. Okay, so this is our modified internal rate of return that has discounted all all negative cash flows by using the finance rate. We don't have any negative cash flow to discount in this case, and compounding all positive cash flows using refinancing rate of cost of capital, okay, instead of the IRR. So this is our modified rate of return. Now this is the manual, okay. Now let us establish the MIRR using Excel formula. Using Excel. So you start with equal sign, then type MIRR. This one is coming here, I just pick here MIRR. So look on the function bar there. We are told to start with values, okay. So the values are our unlevered free cash flow here, starting from year 0 here up to year 3 here. So those are the values. And then what is needed now is finance rate. So I click on the finance rate section there, and our finance rate, that is the rate to discount future negative cash flows and bring them to the present value. And so the finance rate here is the cost of debt, and for that matter we are getting it from our cost of funds sheet here, where we computed weighted average cost of capital. So the cost of debt is this one, effective after tax rate debt here, okay. So we have already put our refinance, and the last is reinvest rate. So I click on the reinvest rate here in the formula, and the reinvest rate is now our cost of capital as we applied it here at annual cash flow sheet. Is cost of capital, which is in this case weighted average cost of capital, this one here, okay. After that, and then press enter to accept that. Let me put this in the same format like the one we established manual. So I click on the manual rate and then use format painter to paint this to Excel sheet, Excel generated. So we see that modified internal rate of return generated using Excel formula is exactly the one we get using manual way. So this manual way has helped us to explain how actually the modified internal rate of return is computed using Excel formula. Now, in our case here, the positive, all our future cash flows were positive cash flow. Let us consider a scenario where instead of having all positive cash flow, we have at least one negative cash flow at the end of the year. So what I can do here is, let me copy this up to here. copy this and then bring them down here, tap to paste. So let us repeat again here. By unlevered free cash flow, start with sign, pick it from here, press enter. Year, start with equal sign, pick it from here. Compounding factor is going to be the same. Okay, so what I can do is simply start with equal sign, pick this one. The same computations will apply here. Okay, and let me select this to fill this here, and select this to fill them to the end. To fill them to the end of our projected period. Okay, so in this case, let us assume that in year 3, instead of having this positive, we have a negative cash flow, ending cash flow. Maybe, for example, for those projects where when at the end of it you need to expose, you need to sell off or to incur costs of closing your business. Okay, so that cost could be a negative figure. Of course, definitely cost is a negative. It's a cash outlay. Okay, so let's assume that our initial cash flow, instead of 70 of this figure, let's put the negative figure here. Let's assume it is let's say, start with negative number and put, say, 12 million. Okay, let's assume that figure. Okay, so now we need to establish, let me insert okay, let me insert a row there, insert row, and here we compute present value, okay, of future cash flow. And in our case here, this one, so instead of applying compounding factor for this one, we are applying discount factor. So the formula here will change. Okay, so the discounting factor here will be, start with equal sign, open the bracket, 1 plus R, cost of capital. But now we are not applying cost of capital, we are applying cost of debt, because in the formula for modified internal rate of return, negative cash outflows are discounted using finance cost. So our R here is going to be picked from our cost of finance sheet, which is this one. So I close the bracket, 1 plus R, so I close the bracket, raised to n. In this case n is 3. Okay, press enter. So this is our discounting factor for this negative cash flow at the end of the year. So its present value now is simply, the present value now is simply taking equal sign, starting with equal sign, this figure multiply by the discounting factor. So we have the present value. Let me copy this format here so that this one comes out in red. Okay, so we have the present value, and so let me insert another sheet here. Insert a sheet here. Insert, row. Insert row, and then call this sum of present values. Sum of present values. Okay, which is just the original one here. Sorry, here, sum of present value, which is just the original figure here. Start with equal sign, original one here, unlevered free cash flow at year 0, and then plus the one we had computed in year 3, this one. Okay, press enter. So that is our sum of present values. For future values, we have these two components now for year 1 and year 2, and their sum. So future values here for year 1 is simply the same. We apply the same formula here, taking the unlevered free cash flow multiplied by compounding factor. Press enter. So the same is going to apply for year 2. So I'm going to fill this in year 2 also. Okay, so the sum of future value in this case now is start with equal sign. Okay, instead of equal sign, just use this sum here. You sum these two components, press enter. Okay, so our modified rate of return now computed manually is going to be, start with equal sign, then take the sum of future values. Okay, before that, start with the bracket, open the bracket, take this total, divide by initial sum of PV. Because it's negative, we start with negative number, and then pick this figure to turn it to positive, close the bracket, and then to the square root of n. So put the root sign, open the bracket, put 1 divided by n, in this case n is 3, close the bracket, and then the whole of this product you need to minus 1 to establish the compounded growth rate for the figures. Okay, so this is our okay, let me move this to, let me cut this here and press it here, paste it here, and here we say it is our modified internal rate of return IRR, which we have computed manually. Okay, and here we put our MIRR using Excel formula now, which is start with equal sign, type MIRR, this one, I picked this one. So we start with values. As usual, we pick them from unlevered free cash flow, which is from here to here. Okay, and then click on the finance rate in the formula bar in order to input the finance rate that discounts future negative cash flows to bring them to the present value. So I click here on the finance rate in the formula bar and then pick our finance rate from our cost of finance sheet here, which is this one, 14, cost of debt, effective after tax cost, after tax cost of debt, or effective debt rate. And after that, click on the formula bar in the investment rate area, click there, and then put the cost of capital, which we get it from our annual cash flow sheet here. And the cost of capital is our weighted average cost of capital, which is this one here. Okay, then press enter. Okay, let's put the same format of this. This one, let's use the same format here. Okay, we have got different IRR from the one. So what is the problem? Let me see what is the problem here, because this IRR obtained manually should be the same as IRR obtained using the formula. Okay, so let's see what went wrong there. Our for the formula, we took the values, which are these ones, and cost of debt, which we picked there, and cost of finance. Okay, so that is what we did in our computation of. So modified IRR, let's see what went wrong here. We had the last cash flow here was discounted using, okay, in the compounding factor, okay, we use the cost of debt because that is what is supposed to be, and then raised to 3 to get our compounding, and so we discount this. Okay, now instead of discounting, we compounded it. There is where there is a problem. So instead of multiplying by this compounding factor, because we are now discounting, okay, we need to divide to bring it to the present value. So I'm going to adjust the formula here by replacing multiplication with division sign. Okay, press enter. Okay, so after that, then you see our MIRR computed manually is exactly the same as our MIRR computed using Excel. Okay, so to emphasize, our mistake here has just reminded us that negative cash flows are discounted back to bring them to the present value using cost of debt. Okay, and positive cash flows are compounded forward to get their future value using cost of capital in order to establish this modified internal rate of return as is captured by the formula in Excel. So that is all for this presentation. Next time we will proceed with other modern metrics used instead of the traditional ones in order to address the shortcomings inherent in traditional business valuation metrics. Okay, so subscribe to my channel so that you get posted of new content that I'll be sharing relating to this Kaluta projection methodology or these financial modeling tutorials. Bye for now. See you then.